Okay, so in 4.3 in this section we're going to be dealing more with ratios, but this time everything is going to revolve around word problems. So each time we come to a word problem, pause the video and use cubes to identify the important pieces of information. Circle the keywords, underline the question, and box the numbers. And your cubes might look slightly different than mine, but I'm identifying that 2/3 is a number, and we're comparing what Lee makes to the number of free throws that Brian made. And the important thing to notice here is that Brian made more. Really important here. So the first question is, what is the ratio of Lee's free throws? So Lee to Brian. Well, Lee is making 2/3 of Brian's. So remember, fractions are really ratios. So this is telling us that the ratio of Lee to Brian, or maybe Brian to Lee, I don't know, but it's 2:3. And remember that Brian made more. So there's our ratio of Lee's free throws to Brian's free throws. Now it says Brian made 15. So in this diagram I can put 15 down here. And what I'm looking for now is that number. If Brian made 15, how many did Lee make? Well, we're multiplying by 5 to get the 15. So we multiply by 5 over here, giving us 10. So how many did Lee make? 10 free throws. Next example, we have fruit punch. Again, pause the video and use cubes. So with this one, I did a little bit of annotating too. I wrote little notes to myself what the different numbers mean in addition to just circling, because that's really, really important. So the 4-3, that's apple juice to orange juice. In part A, it says total volume is 630. And find the volume of apple juice. So total to apple juice. That's basically what we want to look at. But the problem is, I don't have a number in my ratio that I'm given about the total. But think about this. If I used 4 cups of apple juice and 3 cups of orange juice, what would be the total amount of fruit punch? Well, it would be 7. The ratio they give us, the apple juice to orange juice, that's a part-part ratio. The whole that goes with those parts is 7. So our total to apple juice becomes 7 to 4. And in part A, we know that we have 630 as our total. And what we're looking for would be this other number here. How are we getting from 7 to 630? We're multiplying by 90. What's 4 times 90? It is 360, not 630 milliliters. So we're setting up these ratios and we're figuring out the pieces that we need to begin with, and it's really, really important that you're labeling what the different numbers mean. This total to apple juice, I think that's a really important piece. You got to do a little bit more writing with these to make sure that you actually understand what the numbers are that you're writing. Now, part B, Megan uses 520 milliliters of apple juice, so I want apple juice in my ratio. And we're looking for the amount of orange juice, so apple juice to orange juice. So apple juice to orange juice, the ratio we were given to begin with was 4-3. The 520 is apple juice, and that's the number that we're looking for. Multiplying by 130 to get the 520. 3 times 130 is 390, so the volume of the orange juice is 390 milliliters. The next example involves playing cards, football cards, baseball cards. Again, pause, cube. We're going to go to this bar model that we've used for so many things, and we're going to use the bar to illustrate our ratio. And if you look at the picture that we have here, we have 6 dark bars, or 6 bars total. 5 of them are dark, 1 of them is light, because of the ratio that we're starting with here, 5 to 1. We have 5 baseball cards for every 1 football card. And the total of everything altogether is the 1,380. So we're going to use a picture to help us solve this problem. How many units do we have total? Well, we're taking the 2 parts, the 5 and the 1, to get the whole of 6 parts. The 5 to 1 is a part-part ratio. The 6 would be how many parts there are in this whole. So as we look at this, how many units are equivalent to the total number of baseball cards that we have? There are 6. 6 units total up here. There are 6 things there. So if 6 units are 1,380, to find how many one of these units represents, we're going to do 1,380 and divide by 6 to get that 1 unit is equivalent to 230 cards. And now that we know what 1 unit is representing in this problem, answering the rest of it is relatively easy. So football cards was made up by 1 unit. Well, 1 unit is 230. So we have 230 football cards. The baseball cards was represented by 6 units in this picture, or 5 units, sorry. 5 units would be equivalent to 5 times the 230 that each of these represents. 5 times 230 is 1,150. So the number of baseball cards that we have is 1,150. So these boxes, these bar models, they're something that really can help us solve problems and be thoughtful about these word problems. And honestly, a lot of these are big and scary and hard. Well, not hard, but you have to actually take the time to read and understand what the numbers are representing. The next one. A school raised $18,000 at a charity event. The money raised was shared among 3 charities, A, B, and C, in the ratio of 1 to 3. How much money did each receive? My cubes look like this. How many units are there total? Well, the ratio is 1 to 2 to 3, so there's 1 part, 2 parts, and 3 parts for a total for a whole of 6 units. That means that 6 units is equivalent to $18,000. So to find out how much one of these units is worth, we're going to divide. 18,000 divided by 6. So 1 unit is $3,000. We can diagram this using some boxes again if we really want to. So here's a picture of this, and this would be charity A, B, and C, and we can actually see that there are 6 parts to this whole. We can physically count them. So A is 1 unit, so A gets $3,000. 2 units for charity B, that would be 2 times 3,000, or $6,000. So B receives $6,000. And 3 units, I'm looking at the picture for C, 3 units would be 3 times 3,000 for a total of 9,000. So charity C receives $9,000. So these pictures, these bar models, they can help us to visualize, but they're in no means a necessity to doing the problems. But it's very useful to see sometimes. I have 2 more examples to look at in this section, but to make it a bit more digestible, I'm going to stop here, take a break, go outside and do something fun, then come back and look at these last 2.